Hello, happy Sunday. Happy Sunday day to day. Welcome to my live stream. Very glad to be here. Just kind of trying to get the camera set up, last minute check. Cool. Well, welcome to everyone who wants to see a data science live stream on Sunday. My name is Carl Gold, and I am the data science live streamer on this stream, Carl24K Data Science. Today I have a kind of cool stream for you. It's what I'm calling the Explainable Data Science Smackdown. I will be comparing analytics versus statistics versus machine learning, which I thought was a cool idea for a stream. We'll get more into the details later. But let's see. So, if you've seen my stream before, you'll know that I always start out with a bunch of background and explanation of, this area of data science and the stuff that I'm going to be talking about. So I will just go right into that right now. If you've seen my streams before, you also know I always listen to music. This is copyright-free Twitch streaming music channel from Spotify, courtesy of Kike Virela Regero. Hope I didn't mangle the pronunciation too badly. Here, I'll share the stream music really briefly. Let's see. Well, that's not it, but this is the stream. This is the music we're streaming. No copyright music for Twitch. So let's not have those. Whoa, this thing is like screwing up my video. Anyway, that's the music we're listening to. No copyright music for Twitch, so don't mute my music, Twitch. So let's see. Let me get in. So like I said, I'm going to start by explaining the background for the area of data science. Wait, incoming message. Sorry. JCH507. Hoping to ask a question. I'm getting into data science and my old faithful laptop is done. What would you recommend for a new laptop regarding specs? I want to get it into ML for medical research. Sorry for a long question. All right, well, I was going to say, usually I start off my stream by going on the background about the area that I'm into, but of course, always happy to dive into chat. So, God, what kind of laptop as far as specs? That's a funny question because a lot of data science, if you really need a high-spec laptop or something, or computer nowadays, you should probably think about doing it in the cloud. So that's one angle, is that the computer you need nowadays might not be what you think, because you might better spend your time learning about cloud technologies, whether it's AWS or Azure. You can get a very powerful instance, like if you want to study deep learning. So let me back up and say, I think for most data science training, you don't need that powerful a laptop. On the other hand, if you are going to do bigger data sets, it can help. But then, like I was saying, you might want to run things in the cloud. You want to learn the skills to run things in the cloud, because once you get a job in data science, you're not going to be running that on your laptop. You're going to be running it in AWS or Azure. So, how's that for an answer? Let me know, JCH507, if that is not the answer you're looking for. I mean, I can tell you what laptop I use. I use an older MacBook Pro, so I don't know. And it's good enough for what I do at home, but then at work, we do stuff in AWS. Anyway, so there's one quick chat digression. Now let's talk about what is churn, because you might have seen the cover of the book. Churn is the theme of the data science I'm talking about. Churn is when subscribers, users, or customers, or followers quit, or cancel, or unfollow, or stop coming back. So the churn, it's a funny word. It comes from something called the churn rate, which is the percentage of customers that quit or drop out. So you can have a monthly churn rate or an annual churn rate. But churn is not just a rate anymore. Churn is also a verb, and you can say like the customer churned, or you can even say I'm churning, like I'm churning from Netflix because I'm sick of it, and it's not really true. I don't watch much, but we still don't churn. One of the mysteries of churn is why people don't do it more often. But anyway, Churn is a verb. You can say someone's churning. Churn is also a noun. You can say make a churn report, or even make a report, or even the customer is a churn, because they canceled last quarter. Okay, so JCH507, you think that advice makes sense. Actually, I'm passing on advice that someone gave me several years ago when I was wanted to do some machine learning, some bigger stuff, and I was like, oh, maybe I need a powerful computer. But then instead, I learned how to do it on AWS. Actually, here's a good tip too. If you can use AWS, use Cloud9. Because if you like programming in a graphical user interface, you can use a Cloud9 instance on AWS. And I'm sure Azure must have like a virtual, something like that, virtual VS in the cloud. So there are cloud options for using graphical user interfaces now too. But anyway, I digress. All right, so that's what churn is. So what is fighting churn with data? That's the book that I wrote about fighting churn with data. Well, it's about my experience with companies that had churn problems while I was a chief data scientist at a company called Zora. And you can get the book. It's easy to find. There is a discount code, also not too hard to find. So if you want to get the book from the publisher, use the discount code. What was Zora? That is a company that the product is a platform for many subscription companies to run their business. So you might see the name Zoom right here. Zoom is a word that also became a noun and a verb in the last year because everyone's on Zoom calls in the pandemic. So Zoom runs their subscription side of their business on Zora. So all their customers and all the plans that they're on are all tracked in the Zora system. And they log into Zora to, adjust your subscription or upgrade your plan or give you a credit for, bad service or something. Anyway, so a lot of companies use Zora to manage their subscription business. And while I was the chief data scientist there, I did a lot of this churn analysis stuff. And that's where I, got into writing a book about it. So that's kind of the background, why I'm here. Always tell that at the beginning of the stream. So why learn about churn? I always throw this out real quick. It's the most common data science problem because every company or product in the world nowadays wants to have recurring revenue and customers coming back. So churn is super common, but there are special techniques. It's unlike many other problems in data science. And the way I teach it, it's a great way to learn data science foundations because we go from raw data to actionable results. Looks like I'm covering up some of my text there, but that's fine. So anyway, that's why you should stick around and learn this stuff. And what does fighting churn really mean? It actually means using data to reduce churn. I'll just go through real quick the ways companies tend to reduce churn. One is to make a great product. Make features and content that your customers love, and you won't have as much of a churn problem to begin with, right? Common sense. But you can use your data to figure out what the best features of your product are in terms of engaging the customers. And I'll go through that later in the stream. Also, you can use your data to target engagement messages and campaigns for customers. That's usually a marketing function. Customer success and support is when you are helping your customers, but you can use data to figure out which customers need your help and then proactively intervene with them. And lastly, you can adjust your sales and pricing to make a plan, a multi-tier plan that has different levels for people. And we'll look at some data for adjusting plans, and pricing later on in the stream too. So these are all the things that real companies do to reduce churn. And so that's kind of the goal of all this. One other thing I want to say to people on the chat, how's my sound volume? Sounds a little bit loud to me. Sometimes, the level on this Spotify channel varies. So if the sound is too loud or too quiet, speak up on the chat. I can make adjustment here. But without any further comments or questions, let's go and say, where's the data? At this point, I've talked for like 10 minutes in this stream. I've got to actually show some data. So let's look at the data that we're going to use for reducing churn and also doing all that explainable data science stuff I was talking about. It all starts in a database. The Social Net 7, the infamous simulation, or it's infamous if you read the book, Fighting Churn with Data, you see Social Net 7 a lot. So this data includes, let's see, it includes events that customers are taking. Let's see, here's an example query. We're going to select events and join with an event type table and limit it to a single account. And we're going to see what we get for this customer. So this is a standard select statement. I'm not going to go into explaining this SQL. I'm just going to illustrate what happens in this churn case study we're going to look at. So this is a customer, and at these times you can see he posted, viewed ads, or she, we don't actually know the gender of this individual. They dislike things, they like things. So this is a social network, and people in this actually do all the things that you do in a typical social network. Actually, they don't always have disliking nowadays. They're more like, positive messaging social networks mostly only have liking. But so we're going to look at this data and then see who churns or who doesn't churn from the social network. And how we know who churns is also in the database. I'm going to take this same account and we can look at the subscription table. So that people have subscriptions, and you can see they're also for individual accounts, and they have start dates and end dates. And this is the data that we use to calculate churn rates and look at who churns, because someone churns when they don't renew their subscriptions. I don't know, this customer doesn't seem to churn. Let's try another one. Let's find a customer who churns. I don't know. It should be someone who runs out of subscriptions. Well, I guess these people churn on June 6th. The truth is the simulation ends in June. Oh, did I mention it's a simulation? That's the other thing I should explain about this data. If we go back to the slide deck, I will mention that this is a simulation. Oh shoot, I left the wrong repo in this slide from last week. But this shows you my GitHub site, which is where you can easily find all the code for the book. I can show you that if anyone's interested or needs help with that. But basically, you clone the repo from the GitHub site, and you need Python and Postgres to run this code because we're using a Postgres database, and you actually generate that data in a simulation. So why are you using a simulation? Because, well, real companies don't really share their data about their customers, and they shouldn't. I mean, it's important data for them. So to teach people the ins and outs of, churn analysis and forecasting, we use a simulation, which is very, very realistic. It's actually, I think, probably the biggest contribution of my book in a way is that there's a cool simulation that gives you a data set that really looks like, a company with churned customers and stuff. So this is saying a branch. Ignore this thing about the 2020-01-0401 branch. I was using that for last week's stream. Everything from this week's stream should just be in the main branch. So if you're following along with the code, that's where you'll find everything that you need. If you do need to run that simulation, it won't get done. You can start it now, but it'll take like 15 or 20 minutes. So you could run it offline and then catch up with the stream later. All right, so the next thing to look at here quickly is the data set. So I'm picking up on this stream based on a lot of previous work. So we started with that data in the database, the raw events we were looking at. And in previous streams, I explained how to convert that into a data set for analyzing who churns and who is retains. Retention, I should mention, is the opposite of churn, if you haven't heard that bit of lingo before. So let's see. So this summarizes what we've got in the data set. And if you've never seen a data set, maybe if you're new to data science or statistics, I can show you real quick. What does a data set look like? It's nothing mysterious. It's actually just a spreadsheet, which I seem to have a filter on. It's just a table of data. This is what a data set is. Each row is one observation of a customer, and all of their metrics or measurements which are measurements of those events. So here you can see that we're measuring, let me scroll over these other ones, the likes per month, new friends per month, posts per month. These are all based on the events we looked at previously in the database. And then we have this outcome here in this column, which is showing who churned and who didn't. Not that many people churned, we can see. Let's see, I can do a quick highlight. So we'll say equal to true. Those are the churns. We'll make them red because churn is bad. So you can see churns are not too common, but they do happen, in the data set. And right, so that is what a data set looks like in general, and it's a standard tool for doing analysis. And the rest of the stream is going to assume you've already got this data set. I should probably just post the data set somewhere, but I don't know. In the book, you have to actually construct the data set, which is actually a key activity. So this summarizes the data set, assuming you've already got one. We have 5% churn. So like I said, the churns are rare, but that's kind of typical for most, businesses. Churn can't be too common or they'd go out of business, right? So for any business which is a going concern, churn should be fairly rare. We've got likes per month, which averages close to 100. New friends per month averages close to 7. But you can see these measurements also have a long tail, meaning some customers have very high values, as you can see if you look at the max. So one lucky person in this data set had 383 new friends in a month. You wonder if those were real friends or if they were just, saying so. But we've got all these different metrics or measurements, and then there's also some other types of measurements down at the bottom. We've got one, days since a new friend, which is an average of 7, but some people haven't had a new friend in up to 100 days. So I wonder if that's related to people churning or not. We're going to go into all that soon. What we're here to look at is how are all these variables in the data set related to churn? And don't worry, we're going to start seeing some code very, very soon to analyze this. Maybe I should do some code right now just to show that there's really code in this stream. Let's look. This summary is produced by listing 5.2, and I can show you that really quick. And we'll get a little bit of code just to show. So this is what you'll see if you've downloaded the code for the book already. And listing 5.2 means it'll be chapter 5, listing 2. And this is a Python script. We're going to be mostly looking at Python code today. And so this is how we can get the stats, the summary of the data set. Let's see, do I have a saved configuration for it? That would be a good one. Let's see, usually I have the good ones saved. I feel certain it was here, but I'm just improvising. So I'll just edit the configurations and make a new one. Because it's very easy to make these configurations once you're set up in the book. This is going to be data set stats, and it has to be listing 5, chapter 5, listing 2 is what I just said. This is how you set up and run a listing from the book. I won't demo this again, but this is just, once. I usually do this in PyCharm. So now I launch it, and here I am at the breakpoint. And the first thing I do is load that data set. We'll be loading the data set a lot during today's stream, but I'm only going to step through it once. So we read the CSV file and set the index to the first 2 columns, which were the account ID and the observation dates. We're effectively using those to identify the data, but we're not analyzing those first 2 columns. Now let's see. We want to turn the churn column into a float for taking the steps. And then the main function we do to get all that summary is use the pandas function describe. If you don't know pandas, it's the data frame package for Python. And we get that summary. I actually take its transpose, and then I add a few other items. So the skew, the 1% and 99% quantiles, and the non-zero. Percentage of non-zero is the number of customers that have the measurement. So that's what we add to the basic summary. And then I just reorder it. So now I can show you in this data frame here, I have basically the content, whoops, view as data frame. This is most of the content of that set of summary statistics. Actually, this is the smaller data set. Here I'm running on only the first 10 or so metrics. But anyway, I just wanted to jump into a quick code demo. The rest of this actually just saves it out. And that is my way of taking the dataset summary. I just build off the standard pandas function and add some extra things that I like to have in it. And so that is how we're going to be running most of the code for today. And so this is the extended summary. It just has more, there's more features or metrics in the dataset. So that's what we're working on today. So what are we really talking about today? I think that was enough review and level setting. So hopefully you know what churn is, what we're trying to analyze, and basically what's in this data set. We want to explain churn, and today's special theme, I think this is special because I don't know that anyone's really done this, is a comparison of explaining churn between statistics, analytics, and machine learning. Now you might wonder, why statistics, analytics, and machine learning? Well, many people have described data science as a multidisciplinary activity. You say, what is data science? And I like to visualize data science as a three-legged stool. Now, brain teaser, why do stools have 3 legs? Think about that one. But anyway, why is data science, why do I visualize it as a stool with 3 legs, statistics, analytics, and machine learning? Well, because in my humble opinion, those are like the 3 pillars of data science, which is a multidisciplinary field, which involves all 3 of these. And statistics is basically using classical methods in mathematics to really prove facts about your data. Analytics is an activity of visualization, typically, and also exploration by other means. And then machine learning is using modern technology to predict very accurately and with minimal effort, preferably. Actually, if you look at my poster on the back here, I've got like my data science. My poster says data science is data process, algorithm, data visualization, and analysis. I don't know if you can read all that back there. That's my poster. But many different people have different breakdowns of what data science is made up of. So I welcome you to in the chat, anyone out there, what is your opinion of like what data science is made up of? But this is a very good breakdown, and I attribute it to Casey Kozarkov. I'm gonna fucking bad French. I'm gonna mispronounce her last name, but Casey, the chief decision scientist at Google, who's also an avid blogger and social media poster. I think I got this breakdown of data science from her, to give credit where it goes. And I like this because it really does kind of summarize 3 different ways to look at a problem. And so for today's stream, we're going to go through all 3 different methods and look at how they explain churn in this data set and compare the strengths and weaknesses of each one. So that is what my special theme for today's stream is. All right, the 3 pillars of data science, explainability, Smackdown, whatever you want to call it. So I think we'll start with analytics, because this is actually the way many people's process in data science goes. You start with analytics. Why? Because it kind of gives you a better intuition and understanding of what's happening, in your data. And it's not very complicated. So for analytics, for churn, if you've read my book and seen my previous streams, you'll know I use a technique called metric cohorts, and I'm illustrating the concept of metric cohorts right here. And you'll see it turns into a visualization in just a minute. But the concept is that in general, the more people use your product, the less they should churn, right? I mean, your most active users should churn the least, and your least active users should churn the most. And so this visualization is a simple test of that most basic fundamental hypothesis of anyone's, online product or service, is that the more people use it, the less likely they are to churn. So here we're saying, okay, you suppose your top cohort of most active people, and this is some measurement, of times per month for each behavior, 31, 52, 27, and these guys have 25% churn rate. Then your middle cohort has 50% churn rate, and the bottom cohort, the least active or most unhappy people, well, in this toy example, they have a 75% churn rate. Let's look at some real data. Now, this is a real case study from a company that I worked with called Clipfolio. Clipfolio is a BI tool, that means a business intelligence visualization product, and this is showing churn rate versus the number of edits per month that the Clipfolio customer makes. So you can see, well, for one thing, you can't see the actual churn rate. There's no numbers for the churn rates in my real case studies, and that's to protect the confidentiality of the case study companies. But you can see qualitatively the very dramatic difference that using the product makes in the churn rate. So those customers who have like 0 edits have the highest churn rate, that's the bottom cohort. And then those customers that have the most edits per month have the lowest churn rate, around 175 edits per month. And that churn rate is like 1/8 of the churn rate of the bottom cohort. So you clearly using the product is strongly related to churn. And this is a very explainable way of looking at churn. We're going to look at the code for this in just a second, but let me hit a few more examples. This is Broadly, which is another case study, a real company. Broadly is a product that companies use to manage their online presence. And that means their online reviews. So this is the number of reviews updated per month for a Broadly customer. And they, Broadly is a tool that helps people manage those reviews. All right, just making the screen a little bit smaller there so that I'm not blocking the text. But you can also see the same characteristic, that there's a steep drop in the churn rate over, the first several cohorts until you get to about the midpoint, and then the churn rate kind of flattens out. And here's one more case study, which is Versature, which is a voice over IP phone service running in Canada. So a very cool company. They also did churn analysis case studies, and they use Zora to manage their customers. So this shows, again, the bottom cohort has the highest churn rate, very rapid fall in churn rates to around the middle, and then it kind of levels off. And what's cool about this as a way of explaining churn is you have a great answer to the question of how much does a healthy customer use the product, right? Because you can just look at the elbow. The elbow, your elbow, this is my elbow here. This is my weak muscles from too much screen time, not enough exercise. But the elbow of the chart shows you where the decrease in churn rate has kind of stopped. So for Versature, it's about 2,500 minutes a month is where the customer crosses over from this unhealthy region to the healthy region. I can back up, and in Broadly, it's about, just 2 review updates per month appears healthy according to this metric. But this is not the best metric for Broadly. But anyway, these are a very interpretable visualization for the cause of churn, whether the behavior is related to churn, and what a healthy customer looks like. I say metric cohorts all look the same when the data is good, because they have this very characteristic shape of the churn rate dropping to the elbow and then kind of leveling out. And that gives you, shows you the impact on the churn rate and what a healthy customer looks like. This is the metric cohort toy calculation. I wanted to get to the code, but it just shows the basic idea. We're going to start with an unsorted data set. Then we sort it by a metric. In this toy example is logins per month. Then you form cohorts by dividing the data into, or the customers into groups. And then you look at the average of the metric and the average of the churn rate in each cohort. And lastly, you make the visualization. So I kind of went through the toy calculation really quick because I wanted to actually get back to some code. I don't like talking so long, or people will think this is a chatting stream when actually this is a coding stream. So let's look at the metric cohort visualization code from Fighting Churn with Data. This is pretty easy to run. So we're going to do listing 5.1. Let's see. Let's see. I think I'm just going to update this one and just say this is listing 5.1. We'll just keep using the same config and reuse it. So let's look at listing 5.1. This is the cohort plot method for understanding churn, which I would describe this as an analytics approach. Why is it an analytics approach? Because, well, we're coming up with a visualization, which is a cool way to understand it and gives you a great intuition. But we're not really proving anything rigorously. We're also not making predictions that rigorously either. So if we want to make a cohort plot, we have to have a data set, a metric that we're going to work on. And in this case, what are we set to? Post per month. So one of the basic behaviors from the social network. And then the suggested number of cohorts. So just like in the previous code example, first we load the data set into a pandas data frame. And then, hey, Alicard Dakaro, thanks for following. And where are you streaming from? I'm just curious about your username. I'm also always curious where people are streaming from. So anyone who wants to chime in on the chat, let me know where you're joining me from. I always love that. Last stream, someone actually told me that they were watching from Singapore, and it was like 6 a.m. there. And I was like, oh my God, that's so cool. I feel, honored that someone would do that. Anyway, so let's go. How do we do the metric cohort visualization that I was just showing you? Let's see. We first load the data, and then we use the qcut function from pandas. And qcut is short for quantized discretization, or quantile-based discretization. I'm actually not quite sure. It's not very obvious, so you might not know about this function. But basically, it divides the data up into groups. That's the discretization part. It divides it up into groups based on the given metric. So, and this one function, we only pass in one variable because it's actually returning a series. So now the groups variable here is now a series of indicators for which group each data point landed in. And we suggested a number of cohorts here, but sometimes qcut ignores your suggestion. Okay, so once we have the series with the groups, you actually use the group by function to calculate the mean of each group. So the first group by calculates the average value for the metric, and the next one calculates the average churn rate in each cohort. I mean, that was the average metric value in each cohort, and the churn rate in each cohort. And next, I put the data into a data frame for convenience. And so now we can see the result of the cohort analysis already. You can see that post per month ranges from around 1 to 170 average for the cohorts. And the churn rate goes from 9.5% down to 1% in those cohorts. And the rest of this listing is just the plotting code. So here we can go through that too. I'll drag in my plot as it appears. So first we draw the curve. That's what our curve looks like. Then we label the axes. I'm a big believer in nicely labeled axes, or else you come back to your own plot in a few months and you're like, I don't know what I'm looking at. Let alone when you try to show it to some other people, like your coworkers or business people. So anyway, then the rest of this is just finishing up the plot. So that's how you do one cohort plot, and I've actually saved that one out in my result folder right here. So you can see that is the plot that I just made. So that's one way to understand churn, but that's only one metric. What about the other metrics? So actually, if you've worked with this data set for a while, you'll know there's a lot of different versions for each listing. So if we want to do a whole bunch of cohort plots now, as you would do if you were following on in the entire book, you go back to the listing and you add versions to the configuration, which means I'm just going to go version here. These are the command line arguments that go to the program if you're running it on the command line. in the IDE, which is PyCharm, it takes care of it for you. So I'm just going to like put these in. I don't know how many I really need. There's a lot of different versions because this is a very heavily used listing in the book. So let's just run through these all right now, and we'll see how long it takes to do a bunch of cohort plots. This will just like, they spits them out really quick. That's it. There's all the cohort analysis done. So that's the code that we just stepped through last minute, and we just ran through it a whole bunch of times really fast. So now what is the output of this is going to be a bunch of these plots. Let's see if I can open them all up and we can step through them without me having to open different apps. It kind of worked. It opened it up in 2 windows. Well, here's the first one. This is post per month. That's the one we were stepping through before. So this shows post per month makes a pretty big difference in the churn rate. If you're below the healthy level, which is around 25 posts per month, you can have up to 9% churn rate. And then it gets down to around 2%. This next one is ad views per month. So actually, viewing the ads seems to reduce the churn rate as well. I don't know if you've seen this one before. If you've watched my previous streams, you know. We'll have more to say about that in just a minute. And you can see it's somewhat less influential than post per month. And the healthy level of ad viewing also seems to be around 25 or 30 ads per month. But it makes less impact than post per month. I've got some more of these guys over here. Let's look at the rest. Okay, this is the impact of unfriend per new friend, which is actually, now we're seeing the impact of a bad behavior. So having a lot of unfriends is bad, especially in relation to your new friends. This lowest cohort is like the people who don't use the service at all, which is worse. And then you can see for people who use the service at least a little bit, increasing unfriends is actually bad, which is what you can see in this ratio. Next one is, let's see, whoops. Getting onto the wrong one. Hey, what happened there? This is unfriend per month, which also looks bad, but it's weaker. That's actually why we went with the ratio. This one seems to be a little bit bad, but you kind of can see more of an impact in relative to new friends. Next is post per message, the ratio of post per message. That one doesn't make a lot of difference. Next is like per post, okay? That one also not making a big difference. So the analytics approach to understanding churn is pretty intuitive, right? But what's the problem? Anyone on the chat see any problem with this approach? It's a little bit overwhelming, is what I would say, when you have so many of these visualizations. This one is reply per message, which also seems a little bit influential. And now here's days since new friend. Now that's actually a really influential negative factor in churn. So the more days since someone has had a new friend is clearly very bad for churn. That might be one of the most influential things we've seen, because the highest churn rate for the worst cohort is like 12%. So we get a whole bunch of these. Where are like the regular ones? Okay, here's a normal one. This is like your basic behavior, like per month, which is like a good thing. And here you can clearly see there's a healthy level of likes, which is around 75 or 80 likes per month. And then above that, it doesn't make as much difference. But it looks pretty similar to posting, which was like our first one. All right, a few more of these cohorts. Here's the cohort for, a metric group. This was a group made of the average of a few other metrics. We'll have more to say that in a few minutes. But the metric group, which is an average of, I think, likes, posts, and ad views, is definitely very influential for churn. And what you see about this one, interestingly, is there's no best level. It just keeps getting better and better. Let's see. So have we covered enough of these? There's a lot of these different plots, as you can see. Yeah. And so what are the advantages of this approach? It's clearly very intuitive and easy to explain to people, what this means. Well, not necessarily the groupings. Let's take one of the really intuitive ones. Here's a good one. Dislike percent. Okay, the more dislikes the customer has, the higher the risk of churn. Unless they have 0, because that means they're not even using the service. And we can see that the best advice is to have a small number of disliking, like below 1%. And then it has a really bad impact on churn after that. So anyway, let me get back to my script here, if no one has any comments or questions. So what do we say about explaining churn with analytics? Advantages. It's very intuitive. I would say it proves itself. You don't really need to go through a detailed proof of, how that data proves their relationship to churn, because it's so easy. You can actually give the spreadsheet of your data set to someone in your company, and they can come up with the same analysis of the cohorts in a spreadsheet. So that's actually really good. Another advantage of this method is that it's easy to find a target for customer health. Like I said, you use the elbow method or just visually inspect the graph, and often you can see that there's a clear level, where a customer becomes, more healthy, and you can give that to the business as the targets for those metrics. So that's another really good advantage, I think, of this analytics approach to understanding churn. Now, here are the disadvantages of this method, in case you haven't thought of them already yourself. One thing is it's hard to rank the behaviors relative to each other. So some of the behaviors, it was pretty clear that they weren't that influential. So, I don't know. Where's one that didn't look very influential? Like this one, dislike per month, not that influential, right? And we saw clearly, dislike per month, like per month is much more influential here than dislike per month. But then when you get into the gray area, and you have so many, so it's hard to say, what's the most influential. The other thing that is hard to do with this approach is it's hard to assess the overall risk for a customer. Because they might be good on one metric and bad on another. So how do you know, overall, if it's good or bad, for that customer? Well, how do you know if that customer is healthy or unhealthy overall? Because they could be healthy on some metrics, but unhealthy on others. So the analytics approach has no way of synthesizing, the different risks and into a combined risk assessment. Also, just for kind of the relative ranking. Well, you can do the obvious ones, but for many other cases, it's harder to do the ranking. Okay, so that is explaining churn with analytics. Next, let's go to the second leg of our stool, or the second pillar of data science, statistics. Many people would say this is the heart of data science. I'd probably go with that. So, how do we explain churn with statistics? Now, this is a kind of repeat from some previous streams. We're going to use regression. More specifically, we're going to use a model called logistic regression. And that is the regression that you use for an outcome which is true or false, or a binary outcome, as we say, if you're already, a statistician or a data scientist. So this is illustrating how you can imagine there's the engagement of the customer, which is kind of an abstract variable, like a normalized score you can use to describe engagement. But then the retention probability is a real measurement, the probability the customer will churn or be retained. So in logistic regression, you have this S-curved function, or a sigmoidal function, if you know that jargon, that converts the engagement score to the retention probability. And then the engagement score is created for each customer from a multiplication of their behavioral metrics, that's just what you saw in the data set, and a weight or coefficient which pertains to the engagement. And that is how you explain churn with statistics, using this mathematical model with a linear multiplication of behavior by a weight or coefficient. And then you use this S-curve function, which is a pretty simple function if you do much math. And then we actually also tuned the regression. What's shown here on the right is the tuning of the number of weights and the amount of weight available for the regression. And we did this cross-validation where we reduced the number of weights. That's what's shown in the bottom here. We started with 21 metrics and reduced them by tuning the regression until you start to see it impacts the accuracy, which is shown here in the top slide. So in this case, you kind of get up to around, you would say the best regression is at the parameter value 0.04. And I explained that parameter kind of ad nauseum in a previous stream. So let's look at the code here. So I mentioned we control the regression with a C parameter. That was what we were showing in the last slide. One parameter, how much weight is available for the coefficients. How do you choose it? You minimize the number of weights while maximizing accuracy. This is all a review from previous stream. And the cross-validation is the comparison where we look at different values of the C parameter and then compare the accuracy. AUC is an accuracy metric, which we also explained in previous stream. I hope I didn't put the AUC slide next. I didn't want to explain all this, really. We're going to get to the code in just a minute, trust me. I was just trying to explain what we do for regression. Oh yeah, so I do look at the AUC in this stream. So this is a reminder of one great way to measure the accuracy of churn forecasting algorithms is to look at the AUC, or area under the curve. And what that metric is equivalent to is, imagine comparing a churn customer to a non-churn customer. The churn customer should have a higher risk forecast from your model, right? Should. If your model's good. So you look at what percentage of the cases your churn customer actually had the higher risk forecast. And then that is your accuracy metric. And it's a good metric for churn. Hey, Koa's gal, thanks for following and welcome to the data science stream. I am going to do some live code in just a minute once I shut up and finish the explanation. So hang in there if you're looking for real code. Oh, hey, Danny Spark, welcome back. Yeah, I had a good rest. Last weekend was actually my weekend off from streaming. I went to the desert and had a good vacation. This weekend was my weekend for streaming yesterday, and I canceled it due to circumstances beyond my control. But I still wanted to do one stream this weekend because it's been 2 weeks since my last stream. And Koaz Gao, welcome as a data science student. Thumbs up. I'm always glad to see people studying data science because Lord knows we need more data scientists in the profession. So where was I? I was basically explaining the AUC accuracy metric for those who weren't already familiar with it. And yes, Koaz Gao, please throw out the questions. It's always more fun when it's not just me talking here. And I will check what the next thing I was supposed to explain was. I think now that I explained that we're going to do a cross-validation using the AUC to pick the best regression C parameter, I must be doing... Oh, I had some animated arrows that I forgot about. I must be cross-validating for the next listing. So we will look at how to cross-validate our own regression. This will be pretty quick, because we've done it in previous streams. And then we'll look at the result and explain the churn. So that said, listing 9.5 is what we should be looking at for cross-validating a regression. And I'll put it in a breakpoint. And Koaz Gal, still waiting for your question, and also if I'm pronouncing your username correctly. Here you go. Can you tell me in short, what is the difference between data engineering and data science? Yeah, well, in short, data engineering is everything that goes into creating your data set. So I showed earlier in the stream, we do have a data set we're looking at for this stream, which is this data of churn customers. Now you might notice in your data science classes, a table like this one is usually the starting point, right? You get a nice table, and every row is an observation, and every column, is a feature or a metric, and you have an outcome. But data science is what you do with this nice table of data. But let me tell you, in the professional world, a nice table of data like this is very hard to come by, and it takes a lot of work to get your data into this nice table. And everything you have to do before getting the data to this nice table is in some way data engineering. Data engineering encompasses data collection technologies like streaming, Kafka, streaming collection technologies, databases, data warehousing, and then all the transformations and data cleaning to prepare your data, because this is cleaned and prepared data you're looking at in this data set. And then also you have to extract the data and also the outcomes. Because remember, I actually showed you, if you were on at the start of the stream, in this data set, we start out with subscriptions. This is the subscriptions for account 937. And then, this is account 938. Let's get back to the metrics. And then here is the events for account 939. So account 939 has this stream of events. How many events does account 939 have? Well, this is limited to 100. But each account has hundreds of events collected in this database. And now how does all that data get into this nice little table is all the data engineering. Also, getting the data into that database is probably data engineering too. That was not a short answer. I actually went really long-winded on you, Coaz Gal. That was a very long-winded explanation of what is data science and data engineering. So in this stream today, we're basically doing data science because we already have our data into the table. But actually in my book, if you look at the book, in case you guys didn't know, I did actually write a book about this. This is what the stream is based on, Fighting Churn with Data. A lot of what I teach in the book is data engineering because it's how do you prepare the data. But I actually believe in like a hybrid of data science and data engineering because the way you do your data engineering has a big impact on the result of your data science. So that's an idea to leave you with, is that it kind of makes a difference. So that's why I teach a lot of data engineering in the book, because if you don't do your data engineering right, your data science isn't going to come out right either. Anyway, let's look at how to cross-validate regression. Looks like I already have a configuration for it. This one up here said reg CV. I should have configurations for a lot of these because I've covered most of this in previous streams. All right. Let's see. So here's how we cross-validate a regression. Not too hard. Just a few lines of code. Because sklearn and pandas are doing most of the work for you. So these are the packages. We're using sklearn logistic regression. sklearn grid search CV is the cross-validation. Oh, thanks for buying my book, Danny Spark. Yeah, there's multiple chapters related to metric creation, and in my humble opinion, those are the heart of the book, actually, because that's what's really not taught in many places. A lot of people will teach you how to cross-validate a regression. Not many people will teach you how to make good features from your raw data. Anyway, so we split our data into an X, which is the fitting variables or the independent variables, and Y, which is the outcome or prediction variable. I use time series split because churn problems evolve in real time. And so you don't want to have a look-ahead bias in your modeling. For score models, I'm using lift and the AUC. We talked about AUC today. I'm not going to go into lift. That was in previous streams. But I put them in a little dictionary here. And then I create my logistic regression object. And I use the L1 penalty liblinear, which means this is a ridge regression, I think, if I remembered my penalties right. And we are fitting the intercept. Now we're going to test the C parameter at this list of points going from 0.64 down to a very small value. That's just the range for the C parameter here for this problem. It varies over orders of magnitude, and don't get me started on why the C parameter is the C parameter. That's all in a previous stream. So let's see. Now we actually do the grid search. I want to show you guys how long it takes to run by showing you the console output. Now I call the fit function, and that's actually going to do it. So 2 folds for each of 19 candidates, 18 fits. I think it's done. Yep, that was done. And the rest of this is a little analysis of the result. The rest of this is how we get to that plot I showed you guys earlier. Whoops, this is not what I wanted to show you. We already looked at these. So now we saved a new output, which is this one. So we just created this plot, which is basically the same one I showed you in a slide earlier. So that's how we cross-validate the regression. But we're not supposed to be cross-validating today. We're supposed to be explaining the regression. So the next thing we have to do is rerun the regression with the best parameter. And here, the best parameter, I think I said it was around the 0.04 level, because the accuracy starts to decline a little bit once you go from 0.04 to 0.02. But you can see that you can get rid of at least a few of the customer metrics, from 13 down to 11. So that's a slight improvement. So we're going to rerun the regression with the parameter set to 0.04 and look at the output, and that's going to be our explanation of churn using statistics. So let's see. So I'm supposed to do listing 9.4, and I have to check that I'm going to do the right version. Let's see. First I have to check my versions. I didn't prepare this. So there's a whole set of configurations that come with the listings in this JSON here. You can see it's organized by chapter. So I want to be in chapter 9, and then I wanted listing 4. I have to find the right version or make a version. See, this says to use 0.02. Maybe I was supposed to use 0.02 for this as the best version. But I think I want to do a 0.0. I said I'm going to do 0.04, so I'll show you how to add a version. I think I did this in another stream and then didn't commit it. But so I will say v6 here, and I just add another entry in the JSON, and it looks like I just need to have one entry. I'm just going to copy this one to make it easier. Copy, paste, and then the most important step is modifying the new entry. So now version 6 of chapter 9 listing 4 is going to be the one that I want. Let's see. So I'll just duplicate this one. So it's chapter 9, listing 4. I said version 6, I think. It was just a moment ago. And now we can see how to do the regression with just a single parameter, and that will give us the result for explaining churn. Because we're going to look at the output of the regression. Because when we looked before at this output, this guy is showing us the accuracy of the model and, like, you know, how many weights, but it's not actually explaining churn yet. So that's why we're going to run the next listing. Let's see. So if I set that right, we will stop once again in the listing here, right? This is the one. So we take our C parameter variable, now set to 0.04. As usual, we split the data into an X and Y, the metrics or features, as well as the prediction variables. Let's see. Then we actually run the regression. See, now I just create a regression and give it the C parameter as a parameter value. And then I call the fit function on the regression. And now I'm actually going to call my custom function, which makes a regression summary. I'll go into this briefly, because this is actually kind of key to the explanation, but I explained it in detail in a previous stream, so I don't want to bore you if you've seen that. I calculate the impact of a one standard deviation difference in a metric as part of the explanation. I'm not going to go into detail on that right now. And then I put that and the coefficients into a data frame. So this here, the coefficient 0, coefficient from the fit model is actually, the weights or regression coefficients, which are kind of the heart of the explanation. You'll see that in just a few minutes. So we put that into a data frame, as well as what I call the retention impact, which is how much difference being one standard deviation above average makes in the explanation. Makes in the churn probability, rather. And then we're just going to save this. So I'm going to save the coefficients out. That's like my little message here. Here, we can see that on the command line when it happens. Saved coefficients to blah, 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 log reg summary. And that's it. I'm actually just going to let the rest of this listing run out. I don't think... We also save the model, which is for further predictions, which we're not really going to do. And I also save out the predictions. But let's look at the summary we saved out, because that's really the heart of the churn explanation. Because remember, the theme of today's stream is explaining it. Well, actually, I'm supposed to show you the result before we go into that. So here I've saved this file. Now this is a little CSV file. And let's just open it up. Let me make sure this is the right one, though. No, this is the right one. Okay, this is the summary of the regression. That's the data set that we already looked at. And we just saved this out by rerunning the regression at our best parameter value. So now these show you the actual weights of the different behaviors. And is this issue of grouping. So I'll explain that again in just a minute after I kind of clean this output up for your viewing pleasure or for your intelligibility. So I'm going to highlight these also because, actually, not that. I don't want to highlight the offset. I want to highlight just the weights on the metrics. And I pick green for good because that actually means retention and people not churning. And then this column shows the percentage impact in the churn rate. So now what is the explanation for churn that we get from statistics? This is basically it by looking at these coefficients. So the most influential thing for not churning is metric group 2, which is messaging and replying per month. Now that's interesting. The second most influential good thing is likes, posts, and ad views, which is metric group 1. Those metrics were grouped together because they're correlated, and that was all in a previous stream. So I kind of sidestepped that. It makes this explanation a little bit imperfect. But so we had to group those together because they were highly correlated, and regression doesn't work so well when things are highly correlated. On the other hand, there's good information here. Not on the other hand, but moving along, I would say the most negative thing is ad view per post. So having a high excess of ad views per post is the most negative thing for churn, and it reduces the retention rate by 1.3%. That's actually, so let's look at this column to see these percentage impacts. Now this is also makes it very intuitive, which is also why I like doing this as part of my statistics, is converting the model into a direct impact in the churn probability. And it's in terms of being one standard deviation above the average, because that's actually how the logistic regression model works. Again, explained in detail in a previous stream is the fact that the more, you normalize everything so that the average is the midpoint of influence in the regression. And then you look at how deviation from the average affects churn. So this is saying that if you're one standard deviation above average in ad views, your retention rate is going to go down by 1.3%. And 97.2 is the baseline. So what we have here in terms of the statistics explanation for churn is a really clear explanation of how much each metric or behavior influences churn. And you can state that in terms of the impact and the probability. And these are additive, they combine additively. Well, not exactly. A little subtlety. The influence on engagement given by the weights combines in an additive way. If you recall from the explanation of the regression, there is the S-curve. Let's go back to the S-curve. Back several slides. Here's the S-curve, sigmoidal curve. So in that sense, it's not quite a linear, impact. In terms of these don't add. Like if you're one standard deviation above in metric group 2, you get 1.4%. But then if you're also one standard deviation above average in metric group 1, you don't exactly get another 7% impact. So it's a little bit vague. But still, it's really easy to interpret these, I think. You can also you can sort these. Let's do a quick sort to see what, you can really see what are the most influential things here. So we'll sort them by their weight. So you can see from worst to best very clearly, how much difference these makes. And also if you want to chart them, actually let's sort them the other way. Let's change the sort from best to worst. And then if you want to show this to people in your company, a great way to do it is to make a chart like the one I'm about to make. So if you're explaining churn results to business people and you want to explain the regression model, you can make a chart like this and then label it with the metric names. You might have to explain the groups to the people in your company. And so this is a great visualization for showing, okay, what's the most influential variables for churn? Well, metric group 2 is the best for retention, metric group 1 is the next best, and then new friends, likes. The things that aren't really influential are these few in the middle, and then days since new friend, very influential for in a negative way, churn provoking, and also ad view per post. So those are the so that's basically the kind of explanation of churn you can get from statistics. You start from the weights and the coefficients, and then you can actually add this ranking of the influence. All right, so that is explaining churn with statistics. Now, let's just get through these slides again, back up to the summary of explaining churn with statistics. Advantages: intuitive influence ranking by the percentage impact on the churn rate. Simple explanation of combined influence is that it's roughly additive in terms of the impact on engagement. There is a somewhat nonlinear effect in the churn probability. Also, you have an explicit handling of correlation, by which I mean, in the explanation, I said, look, message per month and reply per month are very correlated with each other, so we treat them as a unit. Same for ad views, likes, and posts. I actually think the explicit handling of correlation between the behaviors is an advantage of the statistics approach. Disadvantages of this approach is there's not a distinction between the impact of correlated behaviors. So I'm turning around and saying a disadvantage is, well, you might want to know what is the difference between messages and replies. Is one of them more influential than the other, or what? So you kind of lose that. Also, data preparation is a chore if you do statistics. I didn't go through it in today's stream, but we had to do that whole correlation analysis, group the metrics, normalize the data, and that's all in other streams. So I made statistics look easier than it is in this stream today. We weren't even really using the same data set. Here, I'll show you if I can find it. Let's try to find the regression data set. It should say SocialNet data set 2 dataset 2 group score is what it should be called, if I can find it. Here it is. All right, so this is the data set that we actually use for regression. you haven't seen one of these before. So instead of having metrics on their natural scale, every metric has been turned into like a normalized score, which is like why they're all small numbers. And we've also grouped several metrics. And that was all done through many laborious steps in a previous stream. So this is the regression data set. And that is why I would say, I mean, the truth is, hey, the 3 Lone Ranger. Cool name, by the way. Or is it just the Lone Ranger with the, 3 to make it the? Anyway, thanks for following. Great to have you on the data science team. Always like people who are up for live data science. All right, so that was the end of my explanation of explaining churn with statistics. It's good, very intuitive, simple explanations, but data preparation is kind of a chore. Now, lastly, let's look at explaining churn with machine learning. That was my third pillar of data science, or my third leg of the stool, whatever you want to call it. Usually everyone's favorite because machine learning is the most modern. Oh, here's my slide on what is machine learning. Well, you're learning from data, not programmed logic. And a machine learning algorithm has to not be regression, which basically means machine learning is for things invented in the last 30 years. So that is my simple explanation of what is machine learning. More specifically, we're going to look at a machine learning algorithm based on decision trees, in which you have a tree of rules. Each rule is based on a cut point, on looking at if a metric is above or below a level in the data. And you classify a customer by traversing the tree and making a prediction based on the rules. The terminal nodes give you a prediction. So the first question might be, does the customer have more than 2 new friends per month? Yes. Okay, do they watch less than 20 ads per month? If we say no, then we get down to this question. Do they message more than 25 per month? Yes. Okay, then our prediction is retained. And that's a simple decision tree model. Many people consider decision trees to be interpretable, but they're actually really not, is the sad truth. If you work with these in practice, number one, because a real decision tree might be much larger than this. You'll have many more variables. Number two, we don't really use individual decision trees. We actually use ensembles of decision trees. An ensemble means a group that makes the prediction together. And an XGBoost is extreme gradient boosting, which is one of the latest and greatest, machine learning algorithms. It uses an ensemble of decision trees explicitly constructed carefully, voting in a weighted combination of their outputs to minimize the error on your training data. And I'm not really going to go into the details of how extreme gradient boosting works, but I don't know. You could, chime up on the chat if you want to go into that kind of detail. What we're going to look at is, well, let's fit an XGBoost model. So we have to cross-validate it, and we will go through that now, because that's always fun. Everyone loves cross-validating machine learning models, I think. I think I have a configuration already set up for this one. I should. XGBCV. Let's just make sure it's just a standard. 9 listing 6 version 1. Why is it version 1? I don't remember why this would be version 1. So I'm just going to check the configurations really quick. Why would you be, what was version 1? I might have been doing something else in another stream and I just left it at. Version 1 is, version 1 is the simple data set. We don't want to do that one. We want to do the good data set. So chapter 9, listing 6. We're just going to get into the debugging. So here we are in cross-validating a machine learning model. Now, cross-validation, as I explained earlier in the stream, means testing to find the best parameters for your machine learning model. So, as usual, first we prepare the data by splitting it into the outcome and the explanatory variables. I again use a time series split, and I'm again using the lift and the AUC. I'm also using a log loss on the model here too as part of the fitting. I create the classifier. I'm actually just going to let this function run because it actually takes a little while. Let's go to just let it start running. Ooh, why is it giving me errors? Something bad's happening. Sometimes the debugger just doesn't like these. Let me just rerun this without the debugger, and I'll explain the code while it's running. All right, the debugger is sometimes unkind to me. But so now we're running the cross-validation, and in this case there are these parameters. The depth, which is the depth of the trees, the decision trees that go into the ensemble. The learning rate, which is the parameter for combining the trees. The number of estimators is how many trees to make, and the minimum child weight is a minimum weight to give a tree that does not do good on predictions. So even if they don't do that good, we still want to give them a minimum weight. So we're now with these 4 values of 4 parameters each. We have how many? 256 combinations of parameters. And I said to do 2 fits of the cross-validation. So that's why it says here, fitting 2 folds for each of 256 candidates, totaling 512 fits. And now I have plenty of time to explain the rest of the listing because it actually takes a while to run this cross-validation. So we defined the scoring functions in this dictionary and the test parameters in this dictionary, and we pass them in as the score models, the test parameters, and then we run the fit method on the grid search CV object. And when it's done, I'm also going to put the result into a data frame and sort the values by the test AUC, which means sort by the one that had the best AUC on the test data. And also, a key thing is that I told it to refit the model, which means that the model with the best value will actually be saved for future analysis, which we're going to do, in just a minute. So that's this part down here, where I actually save out in a pickle the model in this xgb model.pickle. Let's see, and this is where we save some predictions. We don't need to look at those today. And lastly, we save a histogram of the forecasts. And I think it's still running, but we can look at some of the old results I have saved. So let's see, what are the results that come out of saving the XGBoost model? Let's see. It's going to be, let's see, dataset 2, cross-validate XGB is actually what our result is going to be called. So this was our old result. This was from the logistic regression. I should close that up. That was our data set. And this is the output of cross-validating the XGBoost model, shown here. I'll zoom in a little bit. So it has a lot of rows, one for each of those 256 parameter value combinations that I told you about. The best parameters are shown here. The best learning rate is 0.2, the best max depth is 1. That's a 1 depth tree, but we combine 120 of them. And this gave us an AUC of 0.8, which is actually pretty good for a churn prediction problem. So this is what comes out of the logistic regression in terms of the summary of the results. But again, this is just explaining the mechanics of the algorithm. This isn't explaining churn yet. So next we're going to look at the explanation of churn. Let's see if it actually finished running. I think it's still running. I might actually just kill this because it takes a long time to run. And the truth is, I've run it in the past, about a dozen times. So that is how you fit an XGBoost model. But let's now go to explaining an XGBoost model. We want to explain churn. We don't just want to, predict churn. So as I introduced in my last stream, just last week, there's a new method for understanding XGBoost models using what's called shapely additive explanations. This is very cool, I think, because it actually makes it not too hard to interpret the inner workings of the XGBoost model. So it's based on game theory, and it analyzes how much does each metric or feature contribute to the prediction of a single example. And then you can look at all the combined results to get a general picture, and also the individual results. So let's just dive in. It's a lot easier to explain the shapely method or the shape method looking at some data and some code. So we're going to use listing 9.8. Now this is actually a new listing that I added after the book was published, honestly, because I didn't know about the shape method when the book came out, but I wanted to bring it to all the users of the book. Anyway, so let's see. So we're going to look at listing 9.8 and make sure there's a breakpoint in it, which there is. And let's see, we want to do, I want to do this one, which is this version actually is going to give explanation for a few customers. So this version has the plot n variable. Well, you'll see in just a sec. Let's just run it. And we'll look at how to use the shapely additive explanation method. I think that's redundant. Shapely method for explaining an XGBoost model. First, we load our XGBoost model from a pickle. I said we saved it when we did the cross-validation. Next, we reload some data, because you need some data to look at to use the shapely method, because it actually looks at the influence of the model on real examples or individual examples. So we reload some data, and then we make what shape package calls a tree explainer, because XGBoost is a tree type method. So we create the explainer, and then we basically just use it. Actually, did you see how it's pausing here? It's actually taking a minute to create the explainer, because it just did a whole bunch of, it ran through all the data values. If you look in this current DF, which has the customers, I can show you this real quick. The current DF, it has 11,000 some odd rows that has all the data for the customers, just like in the data set, remember? So we just did 11,000 explanations, and the first thing we're going to do is make a summary plot, which is from the Shapely library. And here I'll drag it over for you to see it before we save it. That's what we'll look at it more clearly in a minute. It's going to get closed up in a second here and saved, and we can look at it later. And then the next thing we do here is I'm just going to move that. Now, plot n is a parameter I was mentioning, which is telling us how many, what customers we're going to plot from our list of 11,000. So plot n just has a small number. Where is it? Plot n just says 0, 1, 2, 3, 4, 5. So we're going to look at the shapely explanations of the XGBoost model only for the first 5 customers, and we do that simply by calling shape waterfall plot on those rows or those entries of the shape values. And let's see. Here's what a waterfall plot is looking like. Well, again, I'll show you these in more detail once the script runs out. It's going to save all these here too. So yeah, like I said, the rest of this is just saving it. So I'm just going to let the script run itself out now. And then that plot should disappear if my computer doesn't crash. Yep, we're good. All right, so that finished running the script. Now let's look at the actual explanation of the XGBoost model and look at the explanation of churn under the XGBoost model. Let's see. Back to my output folder. Let's find the Most recent things. Okay. This, let's see, where's the overall explanation? Here we go. This is the summary from the Shapely explanation. All right, let's look at this closely. This is very colorful and a little bit overwhelming at first if you've never seen one of these. So each metric or feature is shown on one row of the summary plot. Each dot on the plot is one example. So there's actually 11,000 dots on every row because there are 11,000 examples. They stack up where there are a lot of dots. So you can see that in this region here, there are the most customers. Maybe I should make this like bigger. I'll scroll down later. We'll start out at the top. So red shows that the dot had a high value in the feature, and dark blue shows that it had a low value on the feature. And the most influential variables are shown at the top. So here we're seeing that the most highest values of message per month had a negative influence on the churn rate. And if you go down to the bottom, you can actually see. This is, well, there's a baseline churn rate, which is around 3% in the model. And this is showing you the negative influence on the churn rate in terms of the percentage churn probability. So the most influential people have, in message per month, have a high message per month, and that reduces their churn rate. There's also all these people with low message per month, and that is increasing their churn rate by as much as 15% in some examples. The next most influential metric is new friend per month. Also, high values of new friend per month tend to be associated with reduced churn rate. Low values of new friend per month over here are associated with increased churn rate. But I'll show you some of the funniest thing about this is if you zoom in, you look and you're like, why do these people see these blue dots? They have low message per month, but it's still reducing their churn rate. And these people have low message per month, but it's increasing their churn rate. Well, that's one of the challenges of explaining a tree-based model, is you get some weird discontinuities and nonlinearities like that. The next metric, most influential, is ad view per post. And you can see that customers with high ad view per post, it does increase their churn rate. So that's kind of as expected, in agreement with our analytics and regression. Actually, all these are in agreement with the analytics and regression. Message per month is good, new friend per month is good, and these were some of the most influential variables in the regression as well. Also, ad views were bad, and it was also influential. So you get a kind of similar view of the overall picture of the influence of the variables from the Shapely method as you do from the regression, and the analytics. You can also see these are the least influential variables, and these were also pretty not influential in the regression as well. I want to open that. I closed that regression summary just a minute ago. Let's see. No, it's not one of those. I want to reopen what we were just doing a few minutes ago, but I made so many new files today. Okay, this is it. All right, here's the summary from the regression. So we saw the not influential things were dislike per month, reply per message, post per message. And whoops, that's not it. I want to close this. That was the regression. This is our summary of the machine learning model. So you can see also dislike per month was not very influential. Post per message, a little bit influential, not that much. So largely this agrees with the regression. Now what about explaining individual predictions? Here are some Shapely outputs for explaining an individual customer. And this is called the waterfall plot. So this shows for a customer, this is the baseline churn rate, which is around 0.04 something. This shows for this customer how much difference each feature is making in their prediction. So reply per month for them increased their churn rate. Message per month decreased it by around 1% each. little bit less. Add view proposed increase their churn rate, like per month decrease their churn rate, etc., down onto less and less influential things. And that is how this customer ended up with a 0.0375 or thereabouts churn rate. Or wait, no, I got it backwards. The 037 is the baseline, and then this customer had 0.047. I just explained that all backwards. Well, I was basically explaining it. All right, let's look at another example of the waterfall plot. All right, and we'll read it right this time. If I can bring it over here. All right. So this customer, again, the baseline is 0.037 churn rate. This customer ended up with 0.024 because, let's see, they had a 1% increase in churn due to their new friend per month, a 1% decrease in churn due to their message per month, a decrease due to dislike percent, a decrease due to reply per message. This is showing you their metric values too, etc., etc. And all these things also reduce their churn rate. So that's how customer number 1 ended up with a 0.024 churn rate, or churn forecast probability. So, do you get the sense of how these shape explanations kind of work? You run the data through the algorithm and it will show you for the tree-based model, what difference each metric made. And then in the summary, which we had here, you can actually see the kind of combined scatter, not a scatter, but the combination of all these points gives you a general view of which metrics are most influential, because you can see points far along the x-axis have a big influence, and you can also see what is the direction of the influence of each variable based on the coloring. So that is basically the explanation of churn using machine learning, using XGBoost. You can fit a model with cross-validation and then run your shapely explanatory graphs and plots. Or, also you can save the data from these too. You can save, the data. If you need to explain one given customer, you can get out the data for their waterfall plot like this, and and see how much difference each feature or metric made for that customer. So that is the explanation of churn with machine learning. So, advantages of explaining churn with machine learning. Well, one advantage of XGBoost that of course goes without saying is that it's pretty much the most accurate machine learning model for problems like this. And you really don't have to do any data preparation. All you have to do is save out, that table of the data and run it into your algorithm. You don't need to do the rescaling or worry about correlated metrics. Now, as far as the advantage of this, the explanation using the Shapely method is, it's fairly clear and it's additive. For any given customer, you can say how much each metric, how much difference each feature or metric made to their prediction, and you can add them all up and, get the answer that you're supposed to. So those are fairly good advantages. Disadvantages of this approach, I would say the explanation is still not completely clear, in the sense that you're kind of relying on this algorithm to do some complicated math and give you these values of showing you how much difference each feature or metric made. But that's still not as clear as the simple analytic graph. You pretty much have to hide behind your algorithm and trust that the designers of the method know what they're doing. Now, I believe they do. I'm not saying they don't. But if you want to explain churn to other people, it kind of leaves something to be desired. The other thing I would say that's a challenge with this method for explanation is that the influence of each different feature or variable, it's not robust or continuous. And by robustness means different things. What I mean in this case here is like if you go to this customer, you say, okay, reply per message made plus 1% on their churn probability, and it was the most important. And then I go to this other customer and I'm like, oh, new friend per month was most important for this customer, and for this, and you don't really have a sense of why one thing is most influential or not. You can find weird cases. Actually, let me illustrate it better to you here. You can find the weird cases, like see this blue dot? Like, why is message per month overall a good thing, but this blue dot, this person has a low message per month, but it still reduced their churn probability? Same thing for new friend per month. New friend per month is generally good, beneficial, but for these customers here who had low new friend per month, it was still beneficial. What? Like, why? How does that make sense? That, you know, it's kind of discontinuous in terms of who has what influence. Here's another one where the like per month, it seems like the highest values, the red dots, have only a mid-level of influence, and low values have a higher influence. So you get a lot of these weird questions from tree-based models, and that's kind of the nature of the model. I mean, they're just more complicated. They have a lot of nonlinearity, discontinuities as a result of the tree algorithm that I explained earlier in the stream. So that is how I would summarize explaining churn with machine learning. Some advantages, some disadvantages. So overall, what's the, I don't know, is there a best method for explaining churn? Here's my summary. Fighting churn is about targeted interventions, improvements to your product, engaging with your customers, supporting your customers, and coming up with a good pricing plan. And now, analytics with cohort analysis, it's easy for business people to understand, and it gives really clear advice on healthy versus unhealthy customers using the elbow point that typically appears in those charts. Statistics with logistic regression, it's probably the most interpretable view of the impact of behavior on churn. It does have the disadvantage that it's more work to prepare than machine learning. And lastly, machine learning. The shape method allows you to interpret XGBoost and tree-based algorithms actually reasonably well, much better than it used to be before the shape method was invented, which was just a few years ago. And the advantage, of course, of machine learning with an algorithm like XGBoost is that it's the highest accuracy and the least effort to forecast. So, which method is the best? What is the result of the explainability smackdown? Well, if it's explainability, I'd say it's somewhere between analytics and statistics where you want to go. I mean, obviously, you want your machine learning for forecasting to get the most accurate forecast, and it's good that you can explain it. But if you're trying to explain, I still think the ring has to go to good old statistics, because, I mean, I don't know, it's just easiest to understand with those, you know, linear weights and coefficients and the simple combination of the impact. It is more work to prepare, but actually the work of the preparation gives you the correlation analysis, which also increases interpretability. So it's a little bit more work, but I would say if you really want to explain churn, you should probably use statistics. So I don't know if anyone on the chat has any opinions about that. I don't know. That's kind of my exciting conclusion with this very dramatic music in the background. Again, copyright-free music on Twitch, as always. That was my summary of today's stream. I don't see any new comments in the chat. It's been pretty quiet out there for a while. I don't know if any of those, anyone's still with me? Coaz Gal or Danny Spark? Well, I will just remind you my live stream schedule. Well, it's supposed to be Saturday. I know it's Sunday. I was wondering, is Sunday better for other people than Saturday? I'm actually not really sure. I've been doing Saturday, but sometimes I wonder if I should do Sunday. But I try to do it on weekends, every weekend, and I don't really stream during the week because I have a day job. And yeah, it's no fun streaming after working all day. It's fun watching other people stream, so I do get my streaming in on the weekend, so hopefully you can join me. I also put all these videos on demand on YouTube. I never know why I'm saying this to the Twitch crowd, because all my videos are also saved as highlights, so you can always see them on my Twitch channel. Also, the book, I did write a book. It will give you more detail on all these subjects. And if you want to buy it from my publisher and not on Amazon, you can definitely use the discount code. Get 40% off. It's not a cheap book. I'm sorry. The price is a little bit high, but I don't control the price. I wrote a long book, so the publisher is, charging top dollar for it. But hey, get that discount code and you'll be good. Lastly, please follow me. I don't know if that's the last thing, but please do follow me. That's how I'll give you the updates about my stream schedule, also blog posts and other things that may be doing. I don't tweet or post too much personal stuff. Don't worry, you won't see pictures of my personal life or like my breakfast in my posts. I keep it pretty professional. Talk about churn, data science. I'm starting to post more about fintech because my new job is in a fintech company where we also focus on churn a lot, but it's a different kind of industry. So please follow me, keep in touch on social. And yeah, my next stream, this is what I'll go out with, is going to be on demographic analysis. So yeah, if you've noticed so far in all these streams, I've been talking about what I would term behavioral data. It's like what people are doing on a product or service. But of course, another important subject in churn analysis is demographics, which is roughly saying, what characteristics do you know about a person other than their behavior with a product. So that'll be a really cool stream. Also, first time I've ever live streamed about that, so that'll be exciting. I have some preparation to do, but don't worry. I should get it done by next Saturday, May 1st. And yeah, if no one else has any more questions or comments on the chat, that's it. I'll be back next week. It's been a real pleasure. Thanks for the feedback from people who gave it. I hope you liked my explainability Smackdown. It was a fun topic to do, a good take to put all those methods side by side. So I usually say have a good rest of your weekend, but the weekend's almost over. So just savor the last minutes. I'm actually savoring the last minutes before I go back to work because I had my last week I took vacation. And yeah, these are my last few hours. Glad to spend it here. But anyway, that's it. See you till next time.